This is Jason with Net.Academy. Thanks for joining us today. We're going to be covering IBGP for the most part today. As always, our housekeeping items are to consider giving us a thumbs up and a subscription if you're enjoying the content we're creating. And if you have questions, you can either email me at the email address on the screen right now, or you can just put something in the comments below and I'll do my best to get back to you. That said, let's hop right in. I often tell engineers who don't have a lot of experience with BGP that in a way it's a tale of two protocols, internal versus external. That's probably an oversimplification. However, it's a single protocol, but there are two distinct behaviors depending on whether it's internal BGP or external BGP. And to be clear, when I say internal BGP, what I really mean is BGP within a single autonomous system. And when I say external BGP, I mean BGP running between two different autonomous systems. So for example, if you're an enterprise and you have two routers that you manage running BGP between them, that's IBGP, single autonomous system most likely, right? Especially if it's at the internet edge. And then likewise, if each of them connects to an ISP, ISP-A and ISP-B, you're going to run eBGP from those two routers up to said ISP. Hopefully that makes some sense. There is a dedicated BGP routing table. You see it when you put in the command show IPBGP. It's actually just a subsection of the main routing table, but it has some very important key BGP attributes, things like what is the next hop and what is the AS path. We're going to dive deeper into those probably when we get to our first demo. I think it's just easier to show those things via demo than it is to just talk about them abstractly on slides. And then when you do a show IP route, it will include the BGP routes. However, it will include all the routes, all the IP routes, connected, static, OSPF, eIGRP, BGP, whatever you happen to have. However, those BGP routes will, generally speaking, be missing those key BGP attributes that you get in the BGP table. So there are definitely distinct times when you want to do a show IP BGP and distinct times when you want to do a show IP route. They give different information, even though they're directly related. So what are some of the ways that eBGP and IBGP are similar? Well, they both do triggered updates only, and those updates are batched. This doesn't make a lot of difference to you if you're just running it at the edge of your internet or the edge of your WAN necessarily. Most likely you don't have a lot of routes. Maybe you do. I don't know what your environment is. If you're in an ISP, this is important. This means that BGP is being a very efficient protocol. It's shoving as many routes into a packet before it sends that update as it can. So it's taking, good advantage of packing the TCP packet full of route updates. So I minimize the amount of traffic going back and forth. They both default to very long and hello and dead intervals. By default, it's 60-second hellos and 180-second deads, right? So that's pretty ridiculous. Those are really long. But remember the roots of BGP in general, right? It was meant to be, loop-free and highly scalable. And we did that at the expense of certain enterprise features like being fast or equally using routes or something like that. This is totally editable, and it's pretty common to edit it, and we'll probably talk about that again in another demo. The updates are reliable. They utilize TCP. We've mentioned that. They both have a very policy-centric approach to routing. I can apply a lot of route policies in either direction in either IBGP or eBGP. They're both equally quite scalable, up into millions of routes. Neighbors are always explicitly configured in BGP. You don't just do, like in OSPF, for example, when we went through the OSPF section, we just put a network into OSPF, and if there's an OSPF speaker on that same network, I'll form an adjacency. Does not work that way in BGP. You need to explicitly say, this is my neighbor and this is their autonomous system. And equal cost multipath, or ECMP, while supported, is not automatic in either protocol. Again, that just gets back to the roots of the protocol itself. Okay, so let's talk about IBGP and meshing. Okay, so IBGP by design is meant to be fully meshed. We're going to dive into that because maybe not always, but that was the design intent. It would always be fully meshed. However, that does not mean I'm running a cable between all of my IBGP speakers. Think of it more as a TCP session logical meshing. And we'll have a diagram in a minute to go through what I mean by that. However, there's some downsides. This could lead to many sessions, right? So it's the same formula you would use for any full mesh. If I have 20 IBGP speakers, for example, it would be 20 times 19 divided by 2, or 190 sessions per router. Now, if you think about, you know, an enterprise, maybe they just have 2 IBGP speakers, you know, 2 times 1 is 2, divided by 2 is 1. So I just have 1, you know, session. However, think of an ISP that might have 100 IBGP speakers or something like that, and you can see how that could get out of hand pretty quick. There are a few methods to lessen that burden. The 2 common ones are route reflectors and confederations. I don't think we'll get into either of these. I don't think you're likely to deal with them if you're doing day-to-day BGP work. If you're working on a cert like the CCAE, for example, I would say you really want to know how route reflectors and confederations work. You also want to understand route reflectors if you're doing anything like working in a cloud like AWS. If you're familiar with the Direct Connect Gateway object in AWS, it's basically a route reflector, for example. You want to understand reflectors and confederations also, perhaps, if you're doing an overlay in a data center, right? Something like a spine leaf or a cloth architecture. They can come up there, but those are kind of the corner cases. Most of the time, an enterprise is not dealing with these. However, if I'm wrong, just let me know below and we'll cover it. This full mesh requirement, by the way, is how not to black hole external routes within the autonomous system. So probably next session we'll go a little deeper on how that black holing can occur. So here's what I mean by IBGP meshing. You can see I have physical connections from R1 to R2, R1 to R3, R2 to R4, and R3 to R4. However, R1 to R4 is still a BGP neighbor. R3 to R2 is still a BGP neighbor. Why is that? That is because they still have TCP reachability. So you might wonder how. Well, IBGP is meant to run on top of an IGP. So let's say we have OSPF under the hood. I will take all these 172.16 routes, for example, and put them into OSPF. And then what I will end up with is I can put in a neighbor statement from R1 to R4 using the reachability information from the OSPF table. That might be a little bit convoluted. We will be doing a lab at the end of the IBGP session before we get into eBGP. And you'll definitely get to see what it looks like there if you're confused. Also, feel free to email me or ask any questions below. We'll wrap up here today, but again, this is a little more to do with the meshing. That requirement for IBGP to fully mesh, it's more of a guideline for most enterprises. It's a requirement for most ISPs. The real question here is, would there be a use case for BGP that meshing would be required? Sometimes it's just simpler to keep things isolated. So on the left, we have a drawing where I have two routers in a single data center, but they connect to different ISPs. So I have IBGP potentially running between these two routers, eBGP running from this router here up to this router here in ISP A, and I have eBGP running from this router down here up to ISP B. Even here, IBGP could be considered optional, right? We're going to talk in the next session about something known as next hop self. The IBGP can make that this next hop behavior a little simplified, but it comes at the expense of a little more complexity on your IGP configuration. However, what we do have is I'm probably advertising to these two different ISPs some publicly routable block. I'm just going to assume this is an internet edge for the moment. And both routers are introducing the same public block. That's why you might want to have those meshed. As opposed to, let's look at this drawing on the right. Now I have a west and an east data center. West and east could be a myriad of things, right? It could mean the west and the east side of a particular municipality. In my mind, though, I was thinking west coast and east coast of a country or even a continent. In that case, I'm probably not sending up the same block of routable IPs. If I'm not sending that up, if I'm not expecting, for example, DC West to fail to DC East or vice versa, I probably do not need IBGP between them. There is no continuity between the two that would require it. Hopefully that makes sense, but if not, as always, put some comments below or just email me. That wraps it up for today. I want to thank you for your time. Next session, we'll dive even deeper into IBGP.